Today's class is going to be massive. It's going to be filled with so many things to learn. And trust me, we're going to be talking on the topic number basis. So I know a lot of you have not subscribed to our YouTube channel. Feel free to subscribe to our YouTube channel because we train a lot of young people on mathematics, chemistry related subjects, physics, but we are not focused on biology, but definitely we will see how we can partner with people that can help us to involve you in biology. So we are going to be talking on this topic, number basis. Now, before we go into this topic, I will let you know that we've made a video on conversion or counting in base 2, and also conversion from base 2 to base 10, and also conversion from base 10 to base 2. So that is something that you need to watch. So you can go there and search counting in base 2 with Otasowie. You'll see this video and you will learn a lot from it. So today's topic is number basis. Now, before we go into number basis, I would love to tell you that base 10 counting is known as denary, while base 2 counting is known as binary. We're talking about base 16, we're talking about hexadecimal counting system. So there are so many counting systems which we are going to be analyzing together. Now, before we go into this whole topic, we have to understand that there is a way we convert. There's a way we convert. And also take note that whenever we are dealing with binary, we are only dealing with 0 and 1. So we're talking about binary, that's base 2. We're only dealing with 0 and 1. So 2 is not involved. If we're dealing with base 3, we're dealing with 0, 1, and 2. 3 is not involved. When we are dealing with base 4, we are dealing with 0, 1, 2, and 3. 4 is not involved. Base 5, 0, 1, 2, 3, 4. 5 is not involved. When we are dealing with 6, we have 0, 1, 2, 3, 4, 5. 6 is not involved. 7, 0, 1, 2, 3, 4, 5, 6. 7 is not involved. We have 8, 0, 1, 2, 3, 4, 5, 6, 7. 8 is not involved. Dealing with 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 9 is not involved. I'm so sorry about that. 10. For 10, we are dealing with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, we are not dealing with 10 in this situation. Now let's go to 16. If we are going to be counting 16 will give us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now when we get to 9, we are going to A, B, C, D. Now this is for 10, 11, 12, 13, E, 14, 15 is we have F, which is 15. Remember that we're not going to 16. So we have, for 2 we have 0, 1. 3 we have 0, 1, 2. 4 we have 0, 1, 2, 3. 5 we have 0, 1, 2, 3, 4. 5 we have 0, 1, 2, 3, 4, 5. 6 we have 0. 7 we have 0, 1, 2, 3, 4, 5, 6. 7 we have 0, 1, 2, 3, 4, 5, 6, 7. 8, 9 we have 0, 1, 2, 3, 4, 5, 6, 7, 8. 10 we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 16 we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. Take note. And this counting is known as hexadecimal. Hexadecimal. Remember, hexa is 6. So we are adding plus 10. Remember that 10 stands for what? Decimal. So when you are counting in base 16, it's known as hexadecimal. 6 decimal, 10. 6 plus 10 equal to what? 16. Hexa. Decimal means what? 10 or base 10. So we are counting in base 16. That's what hexadecimal represents. Now we'll be going to the next part, which we are going to analyze together, which has to do with conversion from other bases to denary system. So we're going to convert from other bases. Maybe we want to convert from base 7 or base 8 or base 6 or base 5 to denary. How do we go about it? Do we just sit down and watch it happen? No. We have to learn how to convert from a base to another base. So conversion. We're dealing with conversion now, and we have the following numbers on the board. We have 4, 3, 2, base 5. We're converting it to base 10. We have 1, 2, 3, 7, base 8. We have 6, D, 4F, base 16. Now we have these on the board. Let's convert this and let's see what we'll have. And yeah, so the first one we have 432. I'm going to write 432 now, base 5. Now take note that if we are going to be converting, we are going to raise the powers. So the first one here is 0, 1, 2. 0, 1, 2. So we are going to say equal to 4 times 5 raised to the power of 2 plus 3 times 5 raised to the power of what? 1 plus 2 times 5 raised to the power of 0. So take note, this base is the first thing you will look at. You don't look at the numbers, we look at the base. If the base here is 16, we know we're going to multiply with 16. If the base there is 10, we're going to multiply with 10. If the base there is 20 or anything whatsoever, we're going to multiply with that number, and we're going to raise that number, raise that base to that power. So what we have here is 4 times 5 raised to the power of 2 plus 3 times 5 raised to the power of 1 plus 2 times 5 raised to the power of what? 0. So meaning that we are going to say 4, what's 5 times 5? 25. Plus 3, what's 5 raised to the power of 1? 5. And the next part, 2 times 5 raised to the power of what? 0. Anything raised to the power of 0 is 1. So 4 times 25 will give us 100 plus 3 times 5, which is 15, plus 2. Now we have 100 plus 17 is going to give us 117. Remember, we are converting it to decimal. So if we are converting it to decimal, it's in base 10. And is there need to write base 10 in base 10? No. So our final answer is 117. 117. That's our final answer. So remember, we'll raise it 012. 012. Now that is the focus, 012. Then also we have the next question, which is 1, 2, 3, 7, base 8. Remember, like I said, we'll start from 0, 1, 2, 3. So what we have here is 1 times 8 raised to the power of 3 plus 2 times 8 raised to the power of 2 plus 3 times 8 raised to the power of 1 plus 7 times 8 raised to the power of 0. So remember, 1 times 8. 8 times 8 is 64. 64 times 8. I think that's going to give us 216. Let's check. And if it's 216 or 512, I think it should be 512. 64 times 8, 32. Okay, so it's giving us 512. So what we have here is 512 plus 2 times 64. And now we have 3 times 8 plus 7 times 1. So what we have here is 512 plus 64 times 2, which is 128, plus the next part we have 24 plus 7. So we have 24 plus 7, 12 plus 24. Okay, that's going to give us 159. So 512 plus 159 is 17671. Okay, so what we're having is 671 base 10. Remember that whenever you are going to be focusing your attention on counting in base 10, We don't need to write the base if it's base 10. So what we have here is 24. What we have here is 7. What we have here is 1, 2, 8. So 0, 1, 2, 3. 1 times 8 raised to the power 3. 8 raised to the power 3 is 512. Plus 2 times 8 raised to the power 2. Plus 3 times 8 raised to the power 1. Plus 7 times 8 raised to the power 0. Remember, 8 raised to the power 0 is 1. So 8 times 8 times 8, 512. Now 8 times 8 is 64. 2 times 64, 1 to 8. 3 times 8 is what? 24 plus 7. Now 512 plus 128 plus 24 plus 7 give us 671. Now we have the last question, which we are going to solve together. And in this question we have 6D4F base 16. We're converting it to base 10. 6D4F. 6D4F. So 6, go to write 0, 1, 2, 3. So 6 times 16 raised to the power of 3 plus, remember, we have A, B, C, D, E, F, where A stands for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, and F stands for 15. So now we have D. D is 13 times 16 raised to the power of 2 plus 4 times 16 raised to the power of 1 plus F, which is what? 15 raised to the power of what? It's 15 times 16 raised to the power of 0. So we now have 6 times. Go to multiply 16 3 times. 16 times 16. 6 times 6 times 6. 96. 6. 1. 6. 256. So we're going to multiply 256 by 16 again. And this gives us 6, 3, 33. 6, 12, 15. 6, 5, 2. We have 6, 9, 0, 1, 4096. So we have 4096 here plus 13. We already did 16 times 16 gave us 256 plus 4 times 16, 16, 32, 64 plus 15 times 1. Okay, now we are almost there. We have the next part, which we have 6 times 4096. So let's multiply 4096 by 6. 6 times 6, 36. 6 times 9, 54. 54 plus 3, 57. 0, 5, 24. 2, 4. 2, 4, 5, 7, 6. Let's check again. 6 times 6, 36. 6 times 45 plus 9, 94. 54 plus 3, 57. 75. Okay, so we are going to add plus 256 times 13. 3 times 6, 18. 15, 16. 6, 7. 6, 5, 2. 8. 12, 13. 32, 32, 28. So we're going to add these numbers together and let's see what we can get out of this. This has to do with multiplication, so don't worry, it's multiplication and addition. So the next part is 3, 3, 2, 8, 64, 15. So we have 14 plus 9, that's 23. 23, 7 plus 2, 9, plus 2, 11. 11 plus 7, that's 18. 8, 9, 7, 2. So this gives us 27,983. 27,983. So now we already have our answer. So like I said, we are converting it to base 10, and we just did. We converted it to base 10. So take note, whenever you have converted the number to base 10, you don't need to write 10 again. Not really necessary. Then lastly, I will just give you we'll just talk briefly about conversion of fractions. Conversion of fractions. Like I said, This topic is not going to be too easy, but well, we'll always find a way out to analyze questions like this. So we have conversion of fractions to fraction in other bases to base 10. So we have the question. Let's say we have 12.112 base 3. We have 5/10 base 6, and we have 1.3 base 4. So after we solve this, we'll move to part 2, which we'll release very soon. So for the first question we have on the board, we have 12.112 base 3. Now remember, from here to here is decimal. So whenever you have decimal point like this, 1, 1, 2, from here to here is decimal. From here to here is what we were calculating before. But from here to here is fraction. So the way we are going to count is going to be different. We are going to count here 0, 1, and we are going to count here -1, -2, -3. So we are going to count here 0, 1. We are going to count here -1, -2, -3. And remember that there is a base. So everything we are going to be doing is focused on the base. So we are going to start 1 times 3 raised to the power of 1 plus 2 times 3 raised to the power of 0 plus, we have 1 here now, 1 times 3 raised to the power of -1 plus 1 times 3 raised to the power of what? -2 plus 2 times 3 raised to the power of -3. So we are focusing our attention. 1 times 3 raised to the power of 1 plus 2 times 3 raised to the power of 0 plus 1 times 3 raised to the power of -1 plus 1 times 3 raised to the power of -2 plus 2 times 3 raised to the power of -3. That is the simplest thing to do. You just take it bit by bit. Then now we have 1 times 3 is 1 times 3. 2 times 3 raised to the power 0, anything raised to the power 0 is 1. Plus 1 times 3 raised to the power 1. What's 3 raised to the power 1? So the anything raised to the power 1, you take it down, you bring it down. So we have 1/3. Plus we have 1 times 3 raised to the power 2, which is 1/3 raised to the power 2. Laws of indices. Plus 2 times 3. But now we have 3 raised to the power -3. 1/3 raised to the power what? 3. Let's simplify again one last time. This is 3. This is 2. This is 1/3. This is 1/9. And this is 2/27. 2/27. No, 3 times 3 times 3 is what? 27. 2 times 1/27. 2/27. So now we are going to write 5, because 3 plus 2 is 5, plus the next step is to find the LCM. 3 into 27 is 9. 9 times 1, 9. 9 into 27 is 3. 3 times 1, 3. 27 into 27, 1. 1 times 2, 2. So we have 5 plus 9 plus 3. 9 plus 3 is 12, 14. 14/27. So we have this. The next step is to convert 14/27 to decimal. 14/27 to decimal. So go to this place, go to your long division. 14 to 14. Can it go? No. 0 points. Add 0. 27 times, let's check 5. 27 times 5. 5 times 8 is 35. 5, 135. So this should be 0.5. 5 will give us 135. Subtract, we have 5 left. We add 0. Can it work? 1. So 1 times this is 27. What we have here is 23. Can it work? You add 0 again. And if you multiply that should give you 9 or 8. Yes, 8. You multiply 8, and then you have 5. So meaning that we have 5 plus 0.5185. Now remember, 5, 0.5185. You are going to add them together. 0.000 5.815.5. So meaning that our answer will be 5.5185 in base 10. And that's our final answer. 5.5185. 5.5185. That's our final answer. I know it may look confusing, but it's simple. The next one, we have 5/10. Converting it to 5/10 base 6. are converting it to decimal, converting it to base 10. The first thing is reduce it. What we have here, 1. What do you have here? 2. So we have 1 over 2 base 6, which is 0.5 base what? 6. Now we'll just write 0.5 here. Put down 0, then here write minus 1. 0 is base 6, right? 0 times 6 raised to the power of 0 plus 5 times 6 raised to the power of what? Minus 1, which is 0 times 1 plus 5 times 1, which is 0 times 1 is 0 plus 5. What do we have here? 5. What do we have here? 5. No way we can do this. No way we can do this. You will come again and clean here. What do we have here? 0 times 1 plus 5 times 1 over 6. Remember, this is what? Minus 1. So it gave us 5 times 1 over 6. And what's 5 over 1 over 6? 5 over 6 base what? 10. But can we leave it like this? No. We have to convert it. Take 6, take 5, 0 points. Add 0. 6 times 7, 42. 6 times 8, 48. 48. Subtract it. 20. You check again. 3 can go. 18. 2. 3 can go again. 18. 3 can go again. So it keeps giving us 0.8. 3, 3, 3, 3. Is what? 10. Is there need to write 10? No. It's not important. So our final answer is 0.833 base 10. Then the last one, which we are going to solve for you all, also very simple as well too. We have 1.3 base 4. Now 1.3 base 4, you remember 0 minus 1. 0 times 4 raised to power. No, we are going to write 1 here. 1 times 4 raised to power 0 plus 3 times 4 raised to power minus 1, which is 1 times 1 plus what you have here is 3 times 1 over 4. 3 times 1 over 4, and this is giving us 1 plus 3 over 4. What's 3 over 4? You convert, it's going to give 0.75. You go there and use your long division. Put your 4 here, put your 3 here. 0 point. You add 0. 7 times 4, 28. Minus gives you what? 2. What do you have now? You add 0. 4 into 20, 5. 0.75. So that's why 0.75 plus 1 give us 1.75. Base what? 10. Is there need to write 10? No. So your answer is what? 1.75 as your final answer. So take note. Addition, conversion, every necessary thing in binary, number basis and everything are very simple. But you just have to understand the concept that when there is a decimal, you can count 0, 1, 2, 3, 4, 5. When there is a fraction, there is going to be a difference, which is what? Minus 1, minus 2, minus 3, minus 4, minus 5, down to the end. Take note of this valid point. And trust me, it's going to be a very simple topic for you.